Today, I'm going to show you how I designed and built this 3D printed A-frame for my Aussie ship and how I went from failed parts to a working system. This frame can be used to rescue boats that are stuck at the ponds or to remove a house after a fire. If you're lucky like me, you even might find a treasure. So, I was looking for a special feature for my new RC boat. That's when I had the idea to design a 3D printable A-frame that everyone could make. I searched the internet for some references but couldn't find anything RC related. Then I stumbled on this video. This was even better than the one I had in mind because it rotates more than other designs. Now I needed something to make it rotate and I found this cylinder pushrod. It's supposed to provide 2 kilos of thrust at 7.4 volts. While waiting for my order, I replicated the A-frame and one of the pushrods to figure out the right dimensions. And after a couple of iterations, I got something that worked and was excited to install the actual cylinders on my boat. But this excitement quickly turned into disappointment when those cylinders broke on the day I installed them. They overheated and broke instantly. Useless. At least I got a refund. So I kept searching. I wanted something strong and reliable and found these linear actuators, but these were too expensive, so I got these one instead for 20 bucks. This is called a limit switch. When an object hits this switch, it cuts the current of the motor, or in my case, the actuator. Otherwise, electronics like these can self-destruct. Now, I must come up with a solution to integrate them and readjust the whole frame. I needed them to be smaller, and I wondered if I could place these things somewhere else on the circuit. I called my brother Felix, who knows more than me. He told me that I could solder these things called diodes anywhere else on the circuit, as long as I didn't change the orientation. So this is what I did. This is the electrical diagram if someone wants to build one. Believe me, I was waiting for this moment for weeks. Now, let's add the lights. Like you can see, I glued the parts together. My first intention was to let the upper part of the frame pivot freely, like you can see, but there was too much friction. I tried a couple of tricks that helped, like filling this pulley with lead shut, but in the end, I gave up on this idea. Then it was time to install the frame on the deck of the ship. I thought about gluing it, but it didn't seem right. so I decided to make good use of these inserts I bought. A club member gave me this foam, and I used it to prevent water from entering the hull. Everything is working like it should, and I couldn't be happier. These limit switches do their job perfectly by telling the motors to stop when they should. It's just so satisfying to hear this little... These inserts I installed previously will be used for various things, like this hook to retrieve boats, or this adapter that will serve to install the buoys for our regattas, and other stuff that I haven't figured out yet. Okay, now for the geeks who want to build this too. Here are 3 technical notes I discovered along the way. If you connect the PWM drivers to a variable switch, you'll be able to control the speed of the actuators like me. That's probably the best option. You could also use a 3-position switch, and theoretically you could use one of these available channels for it too. A downside of my design is that the A-frame has almost no strength in this position, but plenty a little higher. I would pay more for good and scale-looking actuators like these, and I think it wouldn't be hard to adapt my design for some other actuators. What would you change in this design? Let me know in the comments, and subscribe if you want to see the next crazy RC build. Thanks for watching, see you in the next one.